Hello, good afternoon. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Shall I start? Shall I start?
Yes, sir.
Give me a moment. We have stopped at this point. Uh, we have found theta p1 and then theta p2 and theta p1 principal stresses, normal stress acting on this plane, tangential stress. Okay, and now I should find uh, this shear maximum shear stress, maximum shear strains, and average stress, and finally I should represent that. Okay, for that, for that, theta p1, which is equal to minus 75.975 minus 75.975. We know that when when theta p1 is negative, then theta s1 is equal to theta p1 plus 45 degree. Therefore, theta s1 minus 75.975 plus 45, which is equal to how much? Theta s1 is equal to how much? Tell me. Minus 75.975 plus 45.
Minus 30.975.
Hmm? Minus how much?
30.975.
Wait a moment. Which problem is this? What is theta p1? Theta p1 we got minus 75.975. Uh, okay, give me a moment. Let me see the problem. Hold on. Three point two four, I think. Yes, 3.24. Okay. Theta is minus 30.960, right? Right? How much? Could you repeat it again?
Minus 30.975, sir.
Okay, minus 30.975 minus 30.975. Theta S2 is equal to theta S1 plus 90. Therefore, theta S2 will be how much? Which is equal to minus 30.975 plus 90. How much will be this?
60.975.
59 point something I am getting. Shall I write the same? 59.037. What? Okay, 60 something.
59.025, sir.
Okay, 035. Okay. Now, see what I've told you. First, we will be getting theta. This is apart from the problem. First, we will be getting theta P1, and then 90-degree apart will be theta P2. Then I will substitute this in sigma n. Then I will get sigma 1 and sigma 2. Similarly, theta S I will get, theta S2 I will get. I will substitute this into sigma t. Then I will get tau max and tau minimum. Tau max and tau minimum are the sign. There is only difference in the sign. If you write plus and minus, that's more than sufficient. Okay, if I substitute theta S1 in sigma t or theta S2 in sigma t, I will get sigma max and sigma minimum. Okay, how to do that? Let us substitute theta S1 in the equation. In the previous class, I have told you tau max was given by this expression. I have directly taken tau max. I took this expression, root of sigma exponential. Either you can use this, but preferably the method we followed, I will use tau max, this expression, what we have found out for sigma normal, sigma tangential. This is the expression I will be using, minus sigma x minus sigma y by 2 sine 2 theta plus 2 tau xy cos 2 theta. Instead of theta, I will be substituting theta s1 for the planes of maximum shear stress, isn't it? In order to find the planes of maximum shear stress, let us substitute theta s is equal to theta s1, theta s is equal to theta s1 in sigma tangential, or sigma tangential which is given by minus, or you can write tau also, no issue, minus of, which is equal to minus of tangential, in the sense this is acting along the parallel plane, sigma x parallel to the surface, minus 2 sine 2 theta. This is s1. You can substitute s2 also. Magnitude only will change. Sorry, sign only will change. Magnitude remains the same. Cos 2 theta s1. A tau max or tau min, which is equal to minus of sigma x. Sigma x is how much? Minus 30, right? Minus 30, 120. Minus 30, 120, minus 30, 40. Minus of minus 30 minus 120 by 2 sine theta is negative, I think. Sine theta is minus 60, sine minus 120 plus tau xy is negative 60, tau xy is negative 40, minus 40 minus 40 cos minus 120. Can you tell me what is tau max or tau minimum? Sorry, I made a mistake. I should substitute minus theta s1. This should be theta s1 2 into maximum shear planes we are obtained. 2 into theta s1 is minus 2 into minus 30, 0.975, 40 cos 2 into minus 30, 0.975. You tell me tau max or tau min.
minus 84.99.
Minus, shall I write minus 85 M?
84 point.
Okay,
Yeah,
85
okay.
MPa. What does the negative sign indicates here? What does the negative sign indicates? Negative sign indicates my shear stress is not in the positive direction. There is a maximum or maximum shear stress is not in the positive direction. It is rotating my S1 place in clockwise direction. Negative sign indicates tau max is rotating S1 phase in clockwise direction, not anti-clockwise. If it is positive, it would have been rotating anti-clockwise direction. This is one. Then we finally will represent it. Plane X, plane Y. With respect to plane X only, I am measuring all the angles. Okay. Next, theta S1. Okay, one more thing we should find. I'll find it here. Sigma average, which is equal to sigma x plus sigma y by 2, which is equal to how much? Minus 30 plus 120 by 2. Therefore, sigma average, which is equal to 45 MPa. Okay. Next, theta S1. Theta S1 is at an angle of minus 30.975 degrees. Just write an certain angle at this angle theta s1. Without, if you want to measure it, you can measure properly and write. Sometimes what they will do, they will see that in the valuation, oh, this is not instead of triangle line, if you draw a line like this, they feel that he has not written properly, has not evaluated properly, and they will see the values. That's it. So properly, you just write it, measure it, and take it. 30.9751 theta s1 perpendicular to that will be, this is plane S1, plane S1, plane S2, plane S2. Okay, and then draw the plane. Okay, next, tau max, which is of magnitude minus 85 MPa, rotating in the clockwise direction. Rotating my body in clockwise direction will indicate this is clockwise direction. 85, opposite phase, opposite sense. This arrow will meet like this. This arrow will meet like this. Sigma average 45 MPa. It is tensile, right? Sigma average on all four faces. Four faces. We should write properly this sketch. So we should write properly sigma average 45. Similarly, 45, 45. Okay. Have you understood this? If you have understood this, there is no need for solving any other problem. I will take another two or three problems. But if you have understood these two problems, all problems are same theoretical. Okay? Shall I go ahead?
Yes, sir.
Okay, I will take one more problem. I'll take the typical problem only, where sigma, I'll take some sigma x minus sigma y. Okay, sigma x minus sigma y is positive. This problem I will take. Yeah. Okay. This is compressive. Okay, compressive angle, right? 90, 90, 60, 60. This is 60, 60, 60. Now you should tell me theta. This is 30 degree. All the sign you should tell me one by one. I will ask one by one. You should tell me participants. Ruti, tell me what is theta. Ruti, tell me what is theta.
30 degrees.
Okay. See, always I told you, top drop. You should drop a vertical from the top. You should drop a vertical from the top. Okay, and that vertical should move towards the hypotenuse like this. Top drop, sweep the clock towards the hypotenuse. Top drop, sweep the 6 p.m. clock, sweep the clock towards hypotenuse. Top drop, sweep the clock towards hypotenuse. If this sweeping, if this sweeping is in clockwise direction, then theta is negative, as in this case theta, if this is 30, if this is 90, this will be 60. Therefore theta, since sweeping is in clockwise direction, theta is minus 60. In case if it gives a problem like this, this sweeping is in anti-clockwise direction. Top drop, sweep the clock 6 p.m. clock towards hypotenuse. This is the hypotenuse. This is 30. Always you should take the angle between the vertical and this plane. This is 30, 90. 90 plus 30 is 120. Remaining is 60. Therefore, this is sweeping is anti-clockwise. Theta is positive 60. Okay. Now, uh, Mekala, tell me what is sigma x?
Minus 60.
See properly. This is right. This is x-axis, right?
Yes, sir.
Sigma x
Minus 90 MPa.
minus 90. Sigma, will tell me
Minus 60 MPa.
tau.
60.
No, check it out. If tau is rotating the phase, this is the x phase. If I write tau xy, it means to say that normal to the plane is in x direction. Tau xy in the sense normal to the plane. X indicates normal to the plane. Normal to the plane is along x-axis, and stress is acting along positive y-axis. When both tau xy, you should see, as soon as you see arrow upwards, if you don't understand this, only upward arrow on x face, this is the x face, upward arrow on x face indicate positive tau. Downward arrow on x face indicates negative tau, and hence in this case is negative 60 MPa. Have you understood this? If you don't understand this conceptually, you remember like this. Okay. Next, is all the parameters. Sigma n. We take that 3.10. Okay. You should calculate. You will note on all the formulas in the sheet and substitute and you should tell me. Simply in each and every problem, you should keep on substituting and take time. Make a note of formula on the sheet. and you can do sigma n, which is equal to, give me a moment, give me a moment. Yes, sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Or I can write sigma n, which is equal to, all are negative, minus 90 minus 60 minus 60 minus 90 minus 60 by 2 plus minus 90 plus 60 by 2 cos 2 theta, theta is negative, minus 60 cos minus 120 minus 60 sin minus 120. Tell me what is sigma n. Minus 150 by 2 minus 75 plus minus 30 by 2 minus 15 cos minus 120 minus 60 sin minus 120. Therefore sigma n is equal to tau nt, which is equal to that angle of obliquity and all you can find. Okay, find from this problem. Tau nt, which is equal to minus of, all this formula should list in the paper. Remember, recall, just mere substitution, sin 2 theta plus tau xy cos 2 theta, which is equal to, minus of sigma x minus 90 sigma y plus 60 by 2 sin minus 120 tau xy minus 60 cos minus 120. Tell me what is tau nt. Yes, what is sigma n? What is sigma n?
Minus
Minus
15.53.
15.53.
Okay, correct. Minus 15.538 tau nt.
17.0096.
17.0096.
17.1 MPa. Next, planes of maximum normal stress planes or principal planes. We'll find out it with formula. And the shear stress planes, maximum shear stress plane, we'll do it by just by substitution with respect to theta 1, theta p1 plane. Okay, that you should remember. Tan 2 theta, which is equal to 2 tau xy by sigma x minus sigma y, or 2 into tau is minus 60 by sigma x minus sigma y minus 90 plus 60, which is equal to minus 120 by minus 30, which is equal to 4. Tan 2 theta is equal to 4. 2 theta is equal to tan inverse 4. Theta p is equal to how much? How much? Raghavendra, mute your mic. Tell me. How much?
75.96.
No, theta p shall I write that is the theta 2 theta p is that 75 and something. 37.98. Okay. Now since sigma x minus sigma y, which is equal to sigma x minus sigma y, which is equal to minus 90 minus 60 minus 90 plus 60 minus of minus 60, which is equal to minus 30, is negative. Therefore 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 theta p indicates the direction of sigma 2, that is theta p is equal to theta p2. This theta p is not theta p, this is theta p2. It is not theta p1, this is theta p2, 37.98 degree. And we know that theta p2 is equal to theta p1 plus 90 degree. Therefore 37.98 minus 90 is equal to theta p1, or theta p1 is equal to how much?
52.0 minus 52.0.
Minus 52.02. Minus 52.02. Next, planes of maximum shear stress. Since theta p1 in this case we do not talk about theta p2. Okay, this is theta p2. Since theta p1 is negative, therefore theta s1 is equal to theta p1 plus 45. Therefore theta s1 is equal to minus 52.02 plus 45. What would be this?
Minus 7.
Minus 7.01. 02. Theta s2, which is equal to theta s1 plus 90 degree. Therefore theta s2, which is equal to minus 7.02 plus 90. Therefore theta s2 is equal to how much?
82.98.
82.98. Last 10 minutes remaining. I will you should tell me quickly. Now in order to find tau max or tau min, which is equal to minus of sigma x minus sigma y by 2 sine 2 theta s1 plus tau xy cos 2 theta s1, or tau max or tau min, which is equal to minus of sigma x, it's minus 90 plus 60 by 2 into sine 2 into this is theta s1, sine 2 into minus 7.01 minus 60 cos 2 into minus 7.01. I'll write myself. Tau max is equal to minus 61.84 MPa. Calculate yourself. Minus 61.84 MPa. Sigma average, which is equal to sigma x plus sigma y by 2, which is equal to minus 60 minus 90 by 2, which is equal to minus 75 MPa. Right? Next, in order to represent that, give me a moment. In order to represent that, I will draw XY. I have to represent principal planes also. X, Y. Principal planes have represented? No. Theta P1 is minus 52.02. Minus 52.0. Clockwise is minus negative minus 52.02. Theta P1 minus 50. You can indicate minus 50. It's actually plus 50. This is 52.02 is anti-clockwise, means it is negative 52.02. Plane P1, perpendicular to it will be plane P2. My sigma 1 is of magnitude how much? Sigma 1 it's sigma 1 we have not found. Heldappa, sigma 1 haven't we found. Sigma normal, sigma tangent should have found. Sigma 1 I have left it. Let me write it here. Sigma 1, I'll write myself. You just see sigma 1, which is equal to sigma x plus sigma y by 2 plus root sigma x minus sigma y by 2 the whole square plus tau square xy. Therefore, sigma 1, which is equal to how much? Minus 13.153 minus 13.153 MPa. Sigma 2, which is equal to sigma x plus sigma y by 2 minus of root sigma x minus sigma y by 2 the whole square plus tau square xy, which will be equal to sigma 2 is equal to minus 136.8465 MPa. Sigma 1, sigma 2 13.153. Therefore, this is planar P1. Sigma 1 I should indicate. Sigma 1 is compressive minus sign. Therefore, it should be indicated 13.153 like this. This is plane P1 13.13. Sigma 2 is also compressive 136.7 MPa 136.84. Sigma 2 is also 136.84. Coming to shear stress plane, maximum shear planes, let me write x, y, theta s1 is at an angle of how much? It is theta s1 minus 52.3. Theta s1 is minus 7.02 degree. This is 7.02 degree. Minus 7.02 degree. I will write this. This is theta s1. This is plane s1. Perpendicular to it will be plane s2. We'll write the plane parallel to this line, perpendicular to it. Okay. Next, theta s1. We can see sigma t. What we got? It is sigma t. Where you got sigma tau max or tau max. Since tau max is negative, after substituting tau max, since tau max is negative, I have already written it rotates S1 phase in clockwise direction. If you have in positive, it will rotate in anti-clockwise direction. 61.84 MPa in clock. This is clock direction. 61.84 MPa. This is clockwise. This opposite. This will be this. This will be like this, right? Next, sigma average we should write, and these planes are also accompanied with the average stress. Average stress is of magnitude sigma average minus 75 MPa. Let me write sigma average minus 75 MPa. This is compressive minus, since this is 75, 75, 75. You should have properly 75. Okay, solve both this problem. Generally, last question to solve this problem by theoretical method. Compare it graphically is the next problem. Next another 20 marks problem is comparing with graphical, same problem. Doing it theoretically and comparing it graphically. From all weightage is for theoretical calculation, half of the weightage is for graphical calculations. I'll stop at this point. Any doubts if you have, you can ask in Google Classroom, or you can call me, or you can mail me. Shall I stop at this point?
Yes, sir.
Yes, sir.
Okay. Thank you.
Thank you, sir.